Hello and welcome to this Telecoms.com webinar delivered in association with AIRCOM International. Self-organizing networks, as the specification defines, or SONs as they've become known, will be instrumental in driving operational efficiencies across a mobile operator's network architecture. The ability to automate key network processes through SONs will deliver significant benefits across an operator's existing 2G and 3G network infrastructure, as well as the future LTE network. But while the technological benefits of SONs are clear, what impact will this network innovation have on an operator's profitability? And what kind of cost savings can network process automation deliver today? And how might these savings increase throughout ongoing innovation? Well, these are questions that are going to be best answered by our speakers today, and we've got three experts lined up. We've got Steve Bowker, who's the CTO of AIRCOM. Good to have you back again with us, Steve. We've also got Jerry Foster, who's the Director of Technology Engineering at AIRCOM, as well as Dr. Mark H. Mortensen, who's a Principal Analyst with Analysys Mason, and I think has done some research work with AIRCOM recently. So I'm going to get things moving straight away, but this is just a reminder that our three speakers will be available after their presentations to take your questions. You can actually type in your questions at any moment during the webinar into the text box beneath the video. Right now, I'm going to hand over to Steve.
Thanks, James. So today we're going to be talking about calculating the true cost savings of SONs. During the last webinar AIRCOM gave with Telecoms.com about 2 weeks ago, we saw that LTE was rolling out aggressively around the globe. There are currently 50 networks commercially rolled out already. And in those networks, we're seeing the first real-life implementations of self-organizing network functionality. The SONs promise enhancements in network efficiency and reductions in CapEx and OpEx, and potentially improvements in customer experience with a reduction in churn. So to date, no commercial analysis has been undertaken to demonstrate how significant the benefits from SON are and how they could impact an operator's profitability. So AIRCOM have produced a model to look at this, and this has been analysed by Analysys Mason. This is what we're going to present today in the webinar. So for the first part of the presentation, we have Dr. Mark Mortensen from Analysys Mason, who is a principal analyst, and he's a lead analyst on their Customer Care and Service Fulfillment Research Program. This program covers self-organizing networks as part of the remit, and we've been working quite closely with Mark and the team there to validate the model that AIRCOM have been developing. In the second part of the presentation, Jerry Foster, who is the Director of Technology Engineering at AIRCOM International, will go on to look at the benefits of applying SON to both UMTS and LTE, and will describe various different scenarios and the benefits of each of those. Full details of the model are described in a white paper, which is detailed at the bottom of this slide, and a link will be provided at the end of the presentation to attendees.
Thank you, Steve. I'll be talking about the business environment associated with really calculating the true cost savings of SONs. I'll be covering three things here. I'll be talking about the situation, the business situation that the current mobile carriers are in, and some of the business imperatives that are driving them. I'll be talking about how SON fits into the picture of their network evolution, both their UMTS evolution and their LTE evolution. And lastly, I'll talk about SON in a very general sense and how it can help the CSPs afford the very extensive upgrade to LTE. Later on, Jerry is going to get into a lot of the details. I'm going to give you really the background here now, and then and the motivators. This is a figure now on the left-hand side that we're all very familiar with. We understand that in the past the mobile networks were dominated by voice, and that now they're becoming dominated by data, that in order to meet those data needs, the mobile operators are building out their networks and putting an awful lot more money into their networks, and that now the network cost is projected to exceed the revenue. Why? Because we're seeing the traffic growing at almost 50%. We're seeing, especially in the developed regions, that the revenue per gigabyte is actually falling tremendously. Here's a number from Analysys Mason, from $23 to about $4 in 2015 in dollars per gigabyte. And that really means that the money coming in is not going to equal the money going out unless something changes. So we know something has to change. The CSPs just can't borrow the money and spend their way out of this problem right now. And by CSP, of course, I mean communication service provider. So we know they have to change the current business model. They know they have to find some fundamental ways to change their cost structure. Let's look at the imperatives then. On the left-hand side is increasing revenue and some of the things that they're doing to increase revenue. On the right-hand side, decreasing costs, some of the things that are going on to try and decrease the cost. So let's look at the increased revenue side. We know the attempt to increase customer loyalty, including getting the quality of service up and the quality of support up. We're looking at more and more bundles of services that help the stickiness of a service. We're looking at specific churn reduction programs that are associated with knowing that a customer is potentially going to churn, calculating their lifetime value, making them special offers perhaps to hold on to them. So loyalty issues. We're seeing marketing and sales being done much more effectively now, including multi-channel marketing, not only having the customer service representative there, but self-service channels and partner channels and kiosks and other areas here that are all the different channels all to interact with a customer, including self-service, including some of the social areas, and making sure that the offers are the same there every place, and making sure that there's a unified shopping cart so that a subscriber can start a transaction in one channel and channel hop over to another marketing and sales channel. And we're seeing even personalized offers. We're seeing much more segmentation of offers and getting right down to personalization of offers, knowing everything you can know about a customer and taking a guess at what they're going to want on the basis of their demographics, as well as perhaps on the basis of social information that's available. So all of those marketing and sales things. We're looking at implementing new services and pricing plans, of course, moving from all-you-can-eat to measured services, going to differentiated services also, and some very interesting things going on here in differentiated and the measured services also. I won't go through all of those. And, of course, looking to machine-to-machine services of the future with some of the Analysys Mason's projections of tens of billions of devices that are going to get connected to these mobile networks over the next decade. And finally, even supplementing with new business models, going to double-sided business models where the mobile operators not only get money somehow from the end user, but also from the other end of the transactions, the other side of the transaction, from a company that the mobile user might be dealing with or a content provider. And finally, even going to some sort of content-based business models. One example of some fascinating things is a mobile operator in an emerging market area that is offering all-you-can-eat Facebook. But that's the only data service. If you do any other data service on your mobile, you actually get charged per megabit. Some very interesting business models that are coming out. So all these things would increase revenue. On the cost reduction side, huge pushes on lots of things, a better network optimization of the radio frequency network, of course, to try and cut the number of towers and the frequencies that are using. Moving to self-care, and not only just self-care, but real self-service operations to try and reduce the back office costs. Trying to optimize inter-carrier settlements by optimizing the network where the network handoffs are happening. Backhaul optimization, all of that backhaul that represents today about 20% of the cost of running a mobile network, and optimizing that, moving over to Ethernet, optimizing the facilities there, going to all kinds of new microwave waves and optical and Ethernet. Going to power conservation, learning how to shut down cell sites and modify the handoff parameters of the neighboring cell sites in order to still give good service in times of low usage. As well as infrastructure sharing between carriers, going more and more to tower sharing and even more intimate ways of sharing network facilities to try and decrease the cost to any one operator of especially LTE increases. The productivity increase of people also, giving them better tools and automating the operations. Even outsourcing the operations in cases where another company can do a better job of outsourcing the engineering function or the operations function, the CSR function. And finally, the standard BSS, Business Support System, and OSS, Operation Support System transformation projects that are done that really attempt to revitalize and redo the back office for, again, lower costs and greater efficiency. All these things are very important. All of these things are going on. And SON fits in here in a couple of areas: increasing the quality of service, providing better radio frequency network optimization, backhaul optimization, the power conservation we talked about, as well as giving productivity increases to the personnel and automating the operations as much as possible. These are very important areas, and we're going to be talking later on, especially Jerry will be talking about the specifics of where these come from. But let me give you a rough idea here. We're talking about SON, and by SON we mean, of course, the self-organizing and self-optimizing networks. SON has benefits all the way through the deployment and maintenance of a mobile network. In the planning time, trying to plan the network and deploying the network, a lot of the self-configuration functions are really going to reduce, especially the OPEX, where a SON device, a SON tower is woken up, finds its place in the universe, talks to its nearest neighbors, and organizes itself and optimizes itself. That, of course, provides a lot of OPEX savings and CAPEX savings also, because it's going to do that in an optimal sense. So the planning and deployment, you pick up some benefits. Again, the optimization and the energy saving functions move in during the optimization and maintenance side here. And again, because the network has found the best way to organize itself given the traffic and the conditions that are going on, you simply need less CAPEX. You need less network in order to support all of that service. So you have both CAPEX and OPEX savings. And finally, the optimization functions really can improve the user experience. We're going to find that's going to be very important to the ROI when you go back and retrofit the SON features not only to LTE but also to the 3G features. Because although SON was originally planned to be an LTE feature, what we found is that the mobile operators are really pushing to have a lot of these very valuable operations features retrofitted back into the 3G networks. And really we're talking about the HSPA and the HSPA Plus technologies. Now why? Well, everyone's doing LTE trials. There's no doubt about that, right? Everyone's been playing with this now for about 1.5 to 2 years. There are a number of LTE deployments, and as you see in this chart here from an Analysys Mason report from Terry Norman, you see that there's LTE deployments that are planned, about 149 that are planned right now, and about 49 that are in deployment or operational, but almost all of them are very small, with the exception of Verizon Wireless, of course, in the U.S., somewhat AT&T in the U.S., but most places LTE is being deployed very tactically. Instead, look at that. Look at HSPA Plus and HSPA, 79 and a plus 169. We're talking a tremendous number of technology, not upgrades here, but capacity upgrades of the HSPA Plus, HSPA networks. So all of those data capacity needs that we see, a lot of that is going to be met by increasing the capacity on the 3G networks. So what that really means now is if you intend to get much benefit from the SON features, you really need to go back and you need to retrofit them. Because LTE is only going to be deployed where it's really dictated by marketing needs. And by that I mean in places where you really do need the higher speeds for marketing purposes, because people just demand the higher speeds. Well, interestingly enough, over a third of the people think they already have LTE. They already think they have 4G because they have an iPhone 4. In any case, LTE is also going to go in, of course, where there's a spectrum availability issue, where there's just not enough spectrum and you need the more efficient spectrum utilization that's provided by LTE. But it's going to be tactical. And the network planning companies right now and companies that provide engineering services and guidance are really helping now all of the mobile operators to understand how they're going to best deploy the LTE tactically, but increase the UMTS capacity, the HSPA, HSPA Plus capacity, and how they should do that the best. I'm going to give you a little idea here of the answer, and Jerry is going to really give you the details of the answer and a lot of the information behind it, but just give you a rough feeling for what the conclusions of this study are. Basically, that if you go ahead and put in a modest LTE, but you backfit the 3G UMTS network with the SON features, which which mostly means software, you can really significantly decrease the costs. And you can really unify the operations across UMTS and LTE. And we're going to find numbers on the order of 25% of total OPEX and CAPEX over the 3-year period. Quite impressive numbers. We're going to find, of course, that each communication service providers, each mobile operator, will have a different sweet spot of UMTS expansion versus the LTE upgrade. And it's going to be really based upon their business needs, particular network situations and topologies, and each one's going to be different. And in fact, you're going to need that help that you're getting now from a lot of these very fine companies. And finally, that actually there's a lot more benefit which can be had from LTE expansion as well as applying SON to the UMTS. And you may find that you actually have a little more CAPEX and OPEX than you expected to be able to spend without increasing your budget very much. So you may actually be able to go into a little bit stronger, faster LTE expansion than you actually first thought. All of these details, all of this will be covered by Jerry in the rest of the seminar here. If you look on number 9 here, you'll find my contact numbers. I'm Mark Mortensen, Principal Analyst at Telecom Software for Analysys Mason. And I've been working with Jerry here on the model. And it's a pretty impressive model, I think you'll agree. So I'm going to turn you over to Jerry now for the rest of the seminar. We'll all be back for questions later. Thank you. Mark Mortensen signing off.
Thanks, Mark. I'm Jerry Foster of AIRCOM International, where I'm Director of Technology Engineering. I lead a team of mobile systems engineering, defining new technology requirements, introductions to our products. And I'm going to talk about hybrid SON cost model that we've developed. I'm going to walk you through an overview of the recent evolution of SON and then describe the basis of our hybrid SON cost model and present our findings. In the 1990s, GSM started to become commonplace. GSM was a relatively simple technology and resultant uptake was fast. GSM has now grown to be the most prolific mobile standard in the world. In fact, one could sum up GSM a bit like a VW Beetle, solid and dependable. In 1997, 3GPP introduced UMTS, which is probably the most comprehensively defined mobile radio standard ever. UMTS has features for fine control of almost every facet, but has proved complex to maintain, and even more complex to optimize. UMTS also proved to be significantly more expensive than GSM in terms of spectrum and equipment. In fact, we could sum up UMTS as a bit like a Concorde, brilliantly engineered but costly to operate. In 2008, 3GPP defined the first cut of LTE, which took the best of GSM and UMTS and produced the world's first data-only mobile radio standard. This system was designed from the outset with cost in mind, and operators spoke about a 40% target cost reduction as compared to the UMTS experience. In fact, summing up LTE with SON, it's an evolution of GSM and UMTS, and a bit like a family car in that it provides good service all round and has affordable running costs. In 2007, mobile operators and vendors were starting to look at the long-term evolution of 3GPP. All parties unanimously agreed that they wanted significantly more capacity for less cost overall, but also were adamant about two requirements aspects of the evolution. The system had to be cheaper per bit than UMTS and its expensive technological complexities. The system had to somehow cost less to run, and any significant additional workforce extension for deployment and operation would make the system non-cost effective. The second of these requirements gave rise to the desire for the networks to self-organize, and the self-organizing networks work item for Release 7 was born, which has now been propagated forward and extended through Releases 8 to 11. SON includes such actions as self-configuration, self-optimization, and self-healing. SON was introduced in standards as being able to be deployed for 3 different types of architecture. Distributed, where the SON algorithm is deployed in the base station or controller. Number 2, centralized, where the SON algorithms are deployed above the network infrastructure, in, for instance, a server connected to the northbound SON interfaces defined by 3GPP. Or 3, hybrid, where the techniques of 1 and 2 are combined to best overall effect. In 2008, with the introduction of Release 8, 3GPP included SON requirements from the outset of LTE and outlined the first few SON algorithms: self-configuration, automatic neighbor relations, and automatic physical cell ID planning, all for LTE. In 2009, the 3GPP standards defined further SON algorithms for LTE. Now, the standards have defined backporting of the first few algorithms to UMTS as well, and provided northbound interface definitions to control some of these algorithms. If we take a closer look at the SON distributed architecture on the left panel, the distributed algorithm typically runs fast as it is close to the radio network, but sees less scope in terms of cells that it can influence. On the right panel, we highlight the centralized algorithm characteristics, which are that it typically runs slower than the distributed system, but sees far more cell scope. Ideally, the most pragmatic and effectual solution is to employ distributed algorithms at the base stations, and then operate a hybrid SON control loop on top. As SON is evolving, in practice, operators and vendors alike offer many different perspective views in the mobile infrastructure market and associated forums on the merits of distributed and centralized algorithms, but most agree that a hybrid solution offers the most beneficial approach. Different equipment vendors offer different distributed algorithms, but all recommended that as a minimum for LTE, automatic self-configuration, physical cell ID, and automatic neighbor relation optimization are essential distributed algorithms for early deployment of LTE base stations. The interest in early standardization has triggered not just equipment vendors to provide SON algorithms. Many tool vendors now also provide centralized solutions for coverage and capacity and load balancing. The limiting factor for good hybrid solutions is the adoption and exposure of the 3GPP defined northbound interfaces for SON, known as the ITFN SON interfaces that are well defined but poorly supported on a lot of equipment so far. The practical experience of many operators deploying SON LTE trials and initial rollouts in the last 2 years has been somewhat different from ideal because a lot of these algorithms do not work well until there is sufficient traffic to feed them to make good optimization decisions. So in the early stages of LTE, some level of initial configuration from the network is essential, and this comes from planning. Slide 5 highlights an evolved hybrid architecture which enables optimization to make use of multiple sources for best performance. Hybrid solutions bring together network resource models, SON northbound control information and performance data from the OMC, plus additional sources such as probe and trace data and readily available planning data sources. The hybrid approach enables the bringing together of planning for initial T0 cell configurations for ANR, for instance, and SON northbound control feeds to recognize when a distributed algorithm is not doing what it should in order to apply an overarching hybrid oversight ANR algorithm, to intervene as required to provide capabilities such as resets, reconfiguration adjustments, and in extreme cases, a new T0 plan as required. Being able to track and monitor live OMC performance data from the distributed ANR PCI algorithms and use this data to feed into hybrid energy-saving algorithms enabled the ability to drive neighbor relations and PCI plans, not just for a T0 reset case, but according to the demand per time of day, when the energy-saving algorithm is seeking the bearer resources or whole cells that can be put into standby during periods of low demand. This white paper considers such applications of SON technology and seeks to estimate the potential savings to operators by deploying these techniques. Slide 6 highlights the cost model assumptions we've made. AIRCOM has over the last year considered the case where key SON algorithms are applied to networks that operate UMTS today and wish to grow an LTE overlay. We assume there is a commitment by the operator to continually roll out LTE over the next 3 years to provide plus 20% of the population coverage of UMTS today at the end of this period. It's further assumed that UMTS expansion also continues in parallel. It is assumed that similar frequency bands are available for LTE as there were for UMTS to get adequate geographic coverage to be cost viable, equating to those around 1800 and 1900 megs. However, it is also acknowledged that in dense urban areas, in order to provide sufficient capacity, 30% of all cells will be rolled out on the higher frequency bands, specifically for LTE of 2.5 and 3.5 GHz. It is also assumed that there is a requirement to provide approximately 1.3 times as many LTE cells as were required for UMTS, due to the use of predominantly higher frequencies and modulation indices, that for most operators, LTE sites will reuse existing GSM and UMTS sites as well. A small percentage of LTE sites are assumed to be located at new locations. Typical deployment costs are used for small cell sites and macro sites, and an assumption is made that there will be twice as many small sites as macro sites, on average. Femto infill is not included in this analysis, as costs of Femto are significantly smaller and usually either domestic backhauled or co-funded backhauled by contracts if enterprise sited. It is assumed that typical mean design bandwidth provision is 2 megabits uplink and 10 megabits downlink for 5 users on average per cell. and at any instant for LTE or UMTS, provision of 14.4 megabits or higher is made, with a few hundred kilobits uplink practically to each user and 500 kilobits to 3 megabits downlink, again for a 5-user mean occupancy per cell for UMTS. Slide 7 highlights the SON deployment approach assumed for the model. It's assumed the key savings are attained from distributed SON, automatic neighbour saving and physical cell ID planning for LTE and ANR scrambling code planning for UMTS, and that a hybrid system applies centralised ANR and cell planning oversight control for the composite single run for T0 planning and oversight adjustment when the distributed algorithms are defined as not operating within bounds. Further, energy saving is operated at the hybrid level and performance management PM, network resource management, and trace data are used to effect a coverage and capacity algorithm in a hybrid form. For distributed SON, neighbour and cell planning deployed at base stations, when there are a reasonable number of mobiles in the environment to stimulate the system, it is assumed that a reduction of rollout costs for LTE and a reduced but notable operational cost for UMTS is realised as long-term and short-term neighbour replanning operations for PCI scrambling code are reduced. Some vendors have advertised and promoted that network operation planning and optimization, or NOPO, costs are likely to be reduced by SON for this application by up to 40% for LTE and 20 to 40% for UMTS. In any mobile system, there will undoubtedly be cases where neighbour and cell planning will not always work perfectly first time. And further, the system will need to be adjusted to accommodate dynamic traffic load over time. From network optimization planning in the days without SON, it is therefore understood by most planners that planning and replanning is usually required a few times after initial deployment for most new sites. Traditionally, manual replanning usually takes the form of 6 monthly to yearly neighbour and cell adjustments. Even so, with these replans, despite a usual 70% replan success rate, there will be some parts of any real network that will undoubtedly require unexpected further attention. In the automated world of SON, we assume for our model that oversight control is used to address this problem using a hybrid SON oversight planning algorithm that responds to cells where the northbound SON OMC interface reports a poorly performing distributed SON algorithm and/or MMRs from these cells, say via minimization of drive test or PM report statistics, are used as inputs to drive the algorithm. We assume savings here from a reduction in expensive secondary site visits and distributed software adjustments to the basic distributed cell planning algorithms. The model further assumes that some form of coverage and capacity optimization load balancing is the next most important saving that can be provided to an operator by application of hybrid SON techniques. This kind of optimization involves the large-scale adoption of automated remote antenna tilts and other key OMC NRM adjustments of parameters such as absolute power and reference powers, plus parameters like individual cell offset values for UMTS and capacity controls such as users per cell admitted and raw limits on RAB, ERAB, radio bearer and data radio bearer and radio link levels to provide operator savings. Application of these kind of SON algorithm techniques reduces the need for further site revisits over a period, as demonstrated by UMTS deployment and subsequent optimization, of between 1 to 2 times per year for the first 1 to 3 years, for a notable fraction of the population of base stations. Without the application of such a SON system, these optimization adjustments are largely manual to both assess and retune, and require expensive site visits, replanning, and manual planning and optimization coordination. Once SON has been deployed to a network to automate cell planning, setup, and coverage and capacity and load balancing applied, then the network operator is empowered with a good understanding of not only how to set up and optimize their network, but also has readily available data on how to dynamically change their network. This capability enables the operator to then use their SON capacity and load data sources to drive energy saving, SON to turn off capacity at low load times, and replan the remaining coverage and capacity to provide only what is necessary for these low demand periods, leaving a low capacity generation general coverage offering in service, but with much reduced but adequate capacity service where subscribers at this reduced load time of day still needed. Slide 8 highlights the financial input basis we've used. The analysis uses operator financial end-of-year reports from 2009 and 2010 that quote revenue and EBITDA by business faction per country in order to assess operator cost breakdown. The analysis takes into account the available data sets in the public domain that detail numbers of base stations per operator for existing GSM and LTE sites and cells of various class. The analysis uses AIRCOM consultancy and permanent staffing costs from its extensive work supporting our consultancy business. Lastly, the analysis uses site expansion and new deployment costs from previous Analysys Mason reports to assess LTE and UMTS re-engineering costs for new rollouts. Slide 9 introduces the first key results findings from the model. For the considered conservative data expansion scenario of slow growth of UMTS and gradual LTE rollout, 1. All types of operator with UMTS, both large and small across all regions, showed a positive NPV on deploying SON. It was evaluated that overall, hybrid energy saving provides the largest saving of the algorithms considered, then distributed ANR, then centralized coverage and capacity optimization like algorithms, and lastly, neighbor and cell planning oversight. Slide 10 highlights the comparative savings from each of the considered SON algorithms. Deploying ANR algorithms in distributed location for LTE has significant savings over the next few years, as adoption of these algorithms reduce initial deployment and optimization costs. Deploying SON coverage and capacity for LTE provides less savings than for UMTS, as capacity is more easily managed in LTE. Energy saving has less benefit in LTE, as newer LTE equipment is already more power efficient than UMTS. However, a lot of UMTS equipment is normally not as efficient as new LTE equipment, and so energy saving has big savings for UMTS adoption. Coverage and capacity has a bigger impact on UMTS than LTE also, as the last benefits of HSDPA and HSPA can be optimized, whereas LTE is naturally better at PRB arbitration for capacity management. Slide 11 illustrates the quantitative benefit of applying SON to the conservative network data expansion scenario. If all operators need to grow between on average 20% data capacity per year, which is half of the current data projections for the mobile business project as a minimum over the next 3 years, through either the adoption of more HSPA and or LTE, then there are vast CapEx and OpEx savings to be made if we compare evolution with and without SON as follows. A. Savings through the adoption of SON as compared to not adopting are 30% of total deployment and operating cost. B. For a smaller operator in Europe, this figure is smallest as it is more difficult to leverage economies of scale in deploying wide-scale SON. Typically here the savings are more like 25%. C. For large operators in Europe, this figure can be larger than 30%, as economies of scale are better across the increased size and density of these kinds of networks. D. For large US operators, the figure is close to the average for all regions and sizes of operator, as the area of scope are very large, but the gains balance out, as there are still some localized very dense areas of population, and hence workforce savings that can be made. 2. OpEx savings through the application of SON are roughly 3 to 1 across the board when compared to CapEx savings, except in APAC where staff costs are still slightly cheaper than Europe and are more like 2 to 1 or less. 3. At the end of the third year of this conservative deployment scenario, it is estimated that the with SON case provides on average a 5% EBITDA improvement as compared to the same deployment case without SON. However, as mentioned earlier, savings are typically greater for the larger operator. Slide 12 provides a set of typical estimated cumulative cost savings for CapEx and OpEx during the considered 3-year conservative scenario data expansion period with and without SON. Slide 13 illustrates a more aggressive data expansion scenario of aggressive LTE-only rollout. Many operators are now rolling out LTE, so we also consider the scenario of aggressive LTE-only rollout over the next 1 to 3 years to address data capacity increase. As an example, the analysis considered a large US operator rolling out LTE with and without SON to produce 75% LTE overlay population coverage as compared to UMTS today within the 3 years. This scenario provides a 2 to 10 times data capacity increase per user on LTE as compared to UMTS HSPA rates today. For this scenario, the model provides the following conclusions. A. 5.53 EBITDA increase per year on average over a 3-year period, which is even better than the slow growth scenario. B. A net SON benefit of an estimated $3 billion for an LTE deployment CapEx cost over 3 years of $6.18 billion estimated. C. The analysis also considered a European operator adopting the same fast LTE-only growth policy, but found this policy far less useful when there are more cities in the same finite area with a higher population density for the country as compared to the US. Lastly, the SON savings presented in this white paper assume no significant increase in revenue, purely a protection of existing ARPU. If the operator manages to preserve or start to charge the ARPU basis in favour of volume charging on, say, a per gigabit basis over time, then the business case for adding data capacity and SON adoption is likely to be enhanced. Slide 14 summarises the key conclusions from the analysis. Number 1, the analysis presented in this white paper estimates that adopting a minimum of 3 coordinated SON algorithms for automatic neighbour and cell planning, coverage capacity optimization, and energy saving as a hybrid SON solution in conjunction with the additional network growth for data capacity over the next 3 years, has a net benefit of approximately 5% EBITDA per year. 2. From a SON savings perspective, aggressive LTE rollout is preferable to slow adoption and ongoing UMTS expansion. 3. Demographics and cost of staff per region need assessing carefully in deciding the best UMTS and LTE rollout combinations per region, size of operator, and ARPU per data user. 4. Whilst the analysis clearly recommends energy saving as the obvious SON algorithm to adopt for best benefit, energy saving is not practical without the adoption of ANR and coverage and capacity algorithms first to enable the algorithm to be realized. So, that's the end of my presentation. Thanks for listening. I'd now like to invite the listeners to our Q&A session, where I'll be online with the other presenters from this session for a short while to answer questions on the on-screen Q&A blog. Thank you.
Thanks, Jerry, and thanks to Mark for the earlier presentation. On this slide, I want to present some of the key findings and recommendations from the work that Jerry did on the model and in the subsequent activities validating it whilst preparing the white paper with Mark Mortensen. Recent standards activities in 3GPP Release 11 have introduced work items to backport SON capabilities to UMTS. Whilst operators are waiting for those to be implemented, centralized or hybrid SON solutions can be applied to UMTS networks. This means that operators do not need to wait for LTE to implement SON, and in fact SON across 3G and LTE networks will give much better returns. The benefits that SON can deliver in a 3G environment are actually significantly larger than can be realized with LTE alone. Operators looking at SON today understand this and are looking for multiple technology SON solutions. Each operator needs to approach SON implementation with care. This is to ensure they safeguard customer experience while maximizing existing network assets, saving CapEx, and increasing operational efficiency, thereby saving OpEx. We would also recommend that mobile operators should work with a credible independent third party to determine their own data evolution path, whether that be to stay on HSPA, HSPA Plus, or to evolve to LTE, and then decide the best SON implementation strategies. Successful operators will undertake a controlled and measured approach to mobile broadband evolution, harnessing SON capabilities across multiple technologies in a time frame that makes commercial sense to them. So to summarise the webinar today, you've seen Mark Mortensen from Analysys Mason provide excellent background information on how the business imperatives of a communication service provider directly benefit from SON. He also pointed out that the current strategies to address the increasing demands for data are mostly focused around enhancing existing UMTS HSPA capacity with targeted LTE rollouts driven by spectrum and market needs. The USA presents an interesting case for LTE, as it's driven strongly by competition between the big players. Jerry Foster from AIRCOM then describes the hybrid cost model his team have built, which clearly demonstrates the benefits from deploying SON across both 3G and LTE. Analysys Mason have validated this model, the assumptions and its findings, and have all been written up in a white paper available on the website, which will appear later. High-level results show that the total cost for network deployment and operations can be reduced by 25%, leading to EBITDA improvements of 5% or more. Savings would be greater in densely populated countries such as Europe. And just as background on AIRCOM related to SON, we have consultants in a number of networks today working on LTE systems which utilize SON functions. We also have a hybrid SON solution based around our iView framework. This leverages our 10-year heritage around OSS solutions, delivering both performance management and configuration management. And we've integrated that with our radio planning tools to provide an overall SON solution. You'll be glad to know we've reached the final slide. I'd like to reiterate that in addition to the slide material presented today, a white paper is available that quantifies the benefits of SON and gives the return on investment calculations for several scenarios of implementing it. The other thing I'd like to point out is in the next 3 months we'll be attending several events, Mobile World Congress in Barcelona, CTIA in New Orleans, and the LTE World Summit later in May. So if you want to meet the team and come and speak to us about the findings, we'll all be there. In addition, you can visit our website to get more information on AIRCOM. So finally, I'd like to thank you all for attending today, and we look forward for your questions, and I'll pass you back to James to explain the logistics.
Okay, thanks Steve, Jerry and Mark for all of your insights there. Great stuff. As I said, now there's going to be time for some Q&A, and our three speakers will be present to take your questions. You just type them into the text box beneath the video, and they'll be posting their replies in real time. Thank you very much for joining us today on Telecoms.com.